In this video, we're going to talk about hints and common errors and math and numbers. So for hints or common errors, we can consider this situation here. The question is, who was the first president of the United States? And the student submitted the answer, Thomas Jefferson. So we'd like to have a very detailed hint for this particular answer, or an answer like this. We'd like to have a hint, something like this. It says, well, Thomas Jefferson was one of the founding fathers. He was not the first president. See, right, these particular pages. So we handle this sort of thing with common errors and hints. And then math, we'll look at how to do this in the context of a problem that has some simple math in it. So we have a number of query templates all set up to help with math. And we can check things like, does this mission include a particular number? Does this mission include a number which is approximately equal to something? Does the submission include a mathematical expression which is equivalent to? Does it have a mathematical equation which is equivalent to something? Does it have a value or a mathematical expression which evaluates to that value? For example, maybe they submitted something and it says 20 divided by 2 is their final result, which evaluates to 10. So we can search for if they have submitted something that is 10 or evaluates to 10. And then also, is there a number which is a power of 10 of a particular value? So I found that these, and there's a few more, that these are very handy for evaluating common errors for math problems. So let's take a look at a particular problem. Oh, it's this problem here. So this problem is the students have to take this equation and plug in the correct values and then solve for p. The correct values are here. So t is this, and then MSS is this times this, and the RTT is this times this, and then they have to solve for p. So many students make mistakes on the units, right? So this is in bytes. You need to convert the bytes to bits. This is in milliseconds. You need to convert milliseconds to seconds, and this is in bits. And then they have to solve it, and the actual value of p is this. So here's the rubric for this problem. There's only one component here. Essentially, did they get the answer right? So first, looking at the component, we have three possibilities that the answer is something includes 10 to the minus 12, e minus 12, which is equivalent to 10 raised to the minus 12, or we say that includes an approximate value of this number with one significant digit. So we're looking for something like 2 times 10 to the minus 12. These are doing text comparisons. Does this exact text appear in their answer? If it does, they probably got it right. Here we're using the LLM, so they may have expressed this in some other way. Maybe they did 10 and they do like an HTML. They submit something where it says 10 and there's a superscript minus 12, or maybe they use LaTeX and it's 10 raised to minus 12. This query here would catch that and would evaluate that to be correct. But these are good and quick, and then if it doesn't have e to the minus 12 or 10 to the minus 12, then we can use this one, and it's quite likely to detect if the answer is correct. If the answer is wrong, then what? Well, then we have these common errors down here. Expand that. So there's a large number of common errors that I've observed in this problem. So I've built this list of common errors to handle each one. So for this one, we see a solution. We see the number 3.3 something raised to the minus 14 within two significant digits. So this happens when they have forgotten they've forgotten this term. Then you would get that value for P. So this is our hint. It looks like you forgot that the packet is in bytes. Well, the data rate is in bits, so you need to do this conversion. Right? So so we detect that particular problem and give a very specific hint. Here's another one. If we detect this number, then it looks like that they solved for the square root of P, and they need to solve for P. So they need to take the square root of that. We don't tell them exactly what to do, but close enough. And so on. We have many other ones, right? So if we see this value, approximately that value, we have this hint. We have a large number of these, all the different things that they could mess up. This handles a case for 2 errors, right? So algebraic error and whatnot. Another case where they made 3 errors, and another one. This one is a little bit different. Here we're asking, did they get a value which is the correct value, but off by a factor of 10, a power of 10. So maybe 10 times too big, 100 times too big, some power of 10. So we can use this query that will look for any kind of power of 10, and then the hint is given, looks like you're off by a power of 10, right? Maybe RGT you didn't realize, or maybe you used the wrong unit someplace. People forget that that gig is 10 to the 9th and so on. In fact, I have it incorrect on here. It should be 10 to the 11th there. So right, so this is a prompt that which can detect off by a power of 10. Another one off by a power of 10 for this one, and then here's a specific hint and more. Now this one, we're looking for this particular equation in the text. So here we're entering in a LaTeX equation. This is the preview of that. So the prompt is going to have LaTeX in it, and we're checking if this expression is in there. We give the LLM this prompt, which includes the LaTeX. You can't see it here because we just have the text here. It's converted into. I guess this is the LaTeX, and this is what it is displayed at. So the LLM is given LaTeX. LLMs can definitely understand LaTeX, and it can, even when the submission is not in LaTeX, the LLM can figure out if this is in the submission, even if it's represented in in regular text or HTML or something. And then we give it an error. We give a message for this, and so on. This could be 2 different possible formulations. And then we have another one, the same idea, where the equation is not quite right. So we detect that they have written down this equation in their submission, this equation or this equation. We see that it's not quite, and we know that it's not the right one. So we give them this error message, and so on. So that's the idea of common errors. Right, we have a list of common errors. I should mention that these are evaluated sequentially. So if they get this wrong, then we check the first common error and see if there's a match. Right, this is it looks like a regular rubric, but we're just looking for if this matches that the student did do this. Then we give them this error. If this comes out to be no, then we check this one. If it comes out no, we check this one, and so on in this sequential order. And you may have noticed that some of these do have overlap, but we evaluate them in sequence. The first one that is found where the answer is yes, then we just output in the comment that particular hint. And if none of them match, or if there's no common errors, if we didn't have any entries here, then the reply would be this more general hint. Okay, so that's how we handle common errors, and that's all of most of the math that we are supporting currently.